Hello, so this is my project video demo for Intelligent Robotics 2, and my project is Human Brain Computer Interface. So in this project, I'm using few electrodes which are connected to my scalp. Four of them are connected to four positions: two on top, two on back of my head, and two on one on each ear. They act as a ground, and I'm using here Open BCI software and open hardware from Open BCI as well. So what happens is here the values from these electrodes are read um, gathered by this ganglion board here, which filters and amplifies the signals and sends it to this Open BCI software over a Bluetooth dongle, and this software displays the values received and its FFT plot. In this project, I do not use this FFT plot here. I just use these time series signal. I pass this signal over an LSL channel to my Python software for collection of data. Um, yeah, so after collecting the data, that data is saved in a CSV format, CSV file, and that data is later processed using some wavelets, using wavelet transformation, continuous wavelet transformation, to get a time frequency analysis. And using that analysis, we train a convolutional neural network model and try to predict what I am thinking. So right now I'll try to um, concentrate just to check if connections of the electrodes are correct. If I close my eyes for a certain duration, then the 10 hertz frequency amplitude should rise and others should remain pretty low. So let's test it. As you can see, the 10 hertz frequency amplitude was quite high for a certain duration, and then it dropped again, dropped back. So using this concept, I'm try to think left or right, or don't think to control something. So my Python code here does is what it randomly generates one label. It will be either don't think left or right, and it gives me 3 seconds before recording, and during that I need to prepare myself to think as per, and then uh, after the countdown is done, it will record my brainwaves for around 2 seconds and save it. So let's go into recording. So I'll probably skip the record. I'll show you one or two recordings because the recording process is quite long, and to take one signal recording, it takes about 10 to 12 seconds. With and usually one recording session lasts for about 10 minutes or something. So for now, I'll just record around 60 to 100 recording waves, and I'll just show you one or two of them. And once I'm completed with other recording all of them, I'll show you the other process of training and testing. So I'll start my process of recording the wavelets. So now I'll start the recording. Okay, okay, so let's start it. I'll think of right. Let's go again. If you see during recording, there was some FFT fluctuations in some frequencies. Now I'm not thinking, and there are some visible changes during thinking and non-thinking process. But there is some uncertainty in between my left thinking and right thinking process. But during training, even if I record these thinking processes left and right individually, I process them together as either thinking or not thinking only, not as left think or right think or don't think, just for initial simplicity. So let's go again. Currently we have three right recordings, but each time it generates right or left, it generates in a random fashion. So and don't think and try not to think anything. So, similarly for left. So another thing about while I'm thinking. So what I do is usually if I am thinking right, I try to concentrate, like clutch my right part of the brain. Um, if you try to do that, you will get used to it later on. You won't be able to understand what I'm telling right away. But once you try to control those waves, you'll understand what I'm saying about. So when I think about that, I try to clutch, like clench my, like how we clench our fist. I try to clench my right part of the brain to have some motion, like to see some control over these waveforms shown in the video. Similarly for the left waves. So I'll pause the recording and I'll record the rest and show you guys about the training and testing. Okay. So I have taken around 60 recordings in this session, and I'll show you these recordings. So as you can see here, this is a Excel file. It's a CSV format. In the first column, it's the label. Two means left. Two means right. One means left, and zero means no thinking. And each of the next columns indicates values presented by each of the electrode for every nanosecond. So this entire row indicates one reading, one reading for right for a complete duration of 2 seconds. And using this recording, we train a neural network. So I'll show you how do we train it just in a second. So this is a Jupyter notebook here to create a neural network and train it. Initially we import all the required libraries, give the training set and testing set. Record file is the training set and the file is testing set, and then we give input shape for neural network. This is a pre-processing function I've written, which pre-processes the waves to have a 3D plot. Um, what does this function does is a continuous wavelet transformation in here for each individual electrode. So we will pass the 2 seconds wave for each electrode, and it will separate them, and it will perform a continuous wavelet transformation for the recording, and we will get a time frequency analysis of that wave, and it will return that 3D plot back to the to where the function was called. So here we create all the training batch training set from. I will open the recorded file and get those information and transform them to the continuous wavelet transformation using this function, and um, start training then a neural network model. So here I'm using convolutional neural network with input size of 80 200. Okay, so as said again, the 2 seconds here, 200 just denotes 200 2 second snap, and it is currently creating those test batches. And here I create convolutional neural network of that input size with two convolutional layers and one dense layer of two dense layers with the first dense layer of 1000 neurons and the second dense layer with output of 2 neurons. So once this is created, we compile it and train it with the training set and save the model. So after saving the model, here is the second pre-processing. It performs exactly same as the previous one, but the only difference being it changes the shape. Um, the reason for creating this new pre-processing function is for predictions. So when I previous function that was to to train the neural network, it needs to have some specific different type of structure dimensions, as you can see in here. So it was trained with this dimensions, but while testing it needs to have a different set of dimensions. So this function does that part. And this later section again performs transformation, but in here it also tries to predict. So we previously created a testing file, so it will take the testing waves and pre-process it and pass to the model we created earlier and try to predict correctly either it is I was thinking or not. And depending on the predictions, it'll try to create a confusion matrix. After this is done, we'll get a confusion matrix. So it is still in the process of training. I'll pause for now and I'll start again when the confusion matrix is done. So after training for 150 bucks, we get an accuracy of 100% with a validation accuracy of 56%, which tells us there has been a lot of overfitting in our training. So which means our data was not sufficient. And again, while testing, it mispredicted a lot of things. So it correctly predicted 21 of non-thinking and 3 of thinking, but mispredicted 35 of non-thinking as thinking and 1 of thinking as not thinking, which is really bad. So from this, there might be some issues. What I feel is like the pre-processing done in here, I'm using Python wavelets, Py wavelets for this continuous wavelet transformation, but I would suggest to have a custom wavelet transformation as per required. And another thing possible might be during recording sessions. The recording sessions were quite long, each day about 10 minutes, 15 minutes. Till then, is 10 to 15 minutes is fine. But if you extend beyond 20 minutes or 30 minutes, one recording session of mine did went about that. Um, After that, I felt I wasn't able to control my brain waves properly. So those improper control must have been added to my training dataset, which must have messed up my training. So that is again possibility. So every time you train or gather the data, please do check if it is valid or not. Do not train the dataset with garbage or any other values. So apart from that, this is my project. This was my first attempt doing this. The second attempt consists of a live training where I try to train the model while I am gathering the data without actually saving it. But I did not test it out yet. There is a possibility it might work, but let's see. But this is my entire project for this term. If I, for EC 550 for EC 579 intelligent robotics 3, and I hope you like it. I hope you can do further in this process. And if you want anything about why did I use CWT, continuous wavelet transform, or any of the um, convolutional network, it is all given in my report. You feel free to check it. Feel free to contact me for anything to either tell me about what can be done to improve this, what I did wrong, what or anything else if you require from me any other information. I'll be glad to help, and I'm also happy to have any input from you. Thank you so much.